Have you ever sent a message out into the void, maybe a hopeful text to an old friend, or even just shouted into a canyon, wondering if anything would come back? Now, imagine that feeling magnified billions of times. Imagine your messenger is a machine flung into the abyss of space nearly half a century ago, suddenly sending back. Not what you programmed, not a malfunction, but something else. Something structured, intelligent, and utterly alien. That's the precipice we might be standing on right now. For 47 long years, NASA's Voyager 1 spacecraft has been our silent ambassador, a testament to human ingenuity pushing the boundaries of exploration. It's the farthest human-made object, currently slicing through interstellar space over 14.5 billion miles away. Think about that distance. It takes light nearly 22 hours to travel from Voyager 1 back to Earth. For decades, it faithfully sent back data about the outer planets and the environment beyond our solar system. But then, in March of this year, something profoundly strange began to happen. Voyager 1 started transmitting data streams that were wrong. Not just slightly off, but corrupted, nonsensical, like a radio station tuned to pure static. Seasoned NASA engineers, the best minds in the business, were completely stumped. They ran diagnostics, checked systems, considered every possibility. Was it the harsh environment of interstellar space finally taking its toll? Was the aging hardware, launched way back in 1977, simply giving up the ghost? It seemed like the most logical explanation for our venerable probe showing signs of, well, electronic senility. But here's where the story takes a turn that belongs more in science fiction than in routine mission logs. Enter the Majorana 1 quantum computing chip. This isn't your standard desktop processor. It's a revolutionary piece of technology that thinks in a fundamentally different way. And when scientists pointed this quantum brain at Voyager 1's seemingly random transmissions, the static resolved into a symphony. The chip decoded what appears to be a deliberate, artificial message hidden within the corrupted data. Let that sink in for a moment. This wasn't a glitch. It wasn't a system failure easily explained away by wear and tear. For the first time, a quantum computer has potentially unveiled an intelligent message, embedded within the telemetry of our own deep space probe. A spacecraft, floating in the unimaginable emptiness billions of miles from its creators, is suddenly broadcasting structured information that was completely invisible to all our conventional computers and analysis techniques. It was hiding in plain sight, masked as noise. Imagine the scene at NASA's Jet Propulsion Laboratory, JPL. Scientists who deal with the predictable laws of physics and engineering tolerances every day are suddenly confronted with data suggesting contact, not a radio signal aimed at Earth from a distant star. As SETI's search for extraterrestrial intelligence programs have traditionally listened for, but something interacting with our technology, using it as a conduit at the very edge of interstellar space. The implications are staggering. It challenges everything we thought we knew about Voyager's lonely journey and forces us to ask, what or who else is out there? Are we truly alone, or have we just received our first cryptic postcard from the cosmic neighborhood? When those first anomalous signals started trickling in back in March, the data looked like absolute chaos. Picture pages and pages of numbers and symbols with no rhyme or reason, complete gibberish. Conventional analysis tools, the sophisticated software NASA uses to decode spacecraft telemetry, saw nothing but noise. Random fluctuations, garbled data packets. It was like trying to read a book where all the letters had been thrown into a blender. The engineering team, quite reasonably, defaulted to the most likely culprit: hardware degradation. After all, Voyager 1 is a marvel of 1970s technology, subjected to decades of radiation and the extreme cold of space. Some components failing wouldn't just be possible, it would be expected. They initiated troubleshooting procedures, trying to isolate the faulty component within the spacecraft's Flight Data System, FDS. the part responsible for packaging science and engineering data before transmission. Here's a glimpse into what they were seeing. Sequences like 10,010,110, 111,001, 11,101,010, but extending for vast lengths, changing unpredictably, offering no foothold for decryption. NASA engineers, brilliant minds accustomed to solving complex problems, threw every traditional decoding method in their arsenal at it. They tried different error correction algorithms, looked for known data formats, cross-referenced with historical telemetry patterns. Nothing worked. The signals stubbornly refused to make sense. But here's the truly baffling part. Instead of petering out, as you might expect from a failing component, the corrupted signals actually started growing stronger and more frequent. This defied all logical explanations based on simple hardware failure. A dying system doesn't usually shout louder, it fades away. This persistent, escalating anomaly pushed the JPL scientists to think outside the box. Conventional methods had hit a brick wall. That's when they decided to turn to a radically different tool, quantum computing, specifically the Majorana 1 chip. Why quantum? Because quantum computers don't process information sequentially, one step after another like traditional computers. They leverage the strange principles of quantum mechanics, like superposition and entanglement, to analyze millions, even billions, of potential data relationships simultaneously. Imagine trying to find the right key on a massive keychain with billions of keys. A normal computer tries them one by one. A quantum computer can, in a sense, try a vast number of them all at once. It excels at finding hidden patterns and correlations in massive, complex datasets, exactly what Voyager's transmissions had become. And when the Majorana 1 chip was applied to Voyager's baffling transmissions, something truly astonishing happened. It was like putting on a pair of magic glasses. The visualization of the data underwent a dramatic transformation. What had looked like random, meaningless static, pure noise, suddenly resolved into distinct, complex geometric patterns when processed through the quantum algorithms. The signal wasn't random at all. It contained precise mathematical sequences that repeated, but with subtle variations, a hallmark of intentionally structured communication, not the chaotic signature of random interference or equipment malfunction. The quantum computer could perceive an order hidden beneath the apparent chaos, an order invisible to our previous methods. It was a needle in a haystack the size of the solar system, and the quantum computer was the magnet that found it. The absolute breakthrough, the moment that sent shockwaves through the scientific team, came when the quantum system identified a specific, repeating sequence of 127 bits embedded throughout the noisy data stream. 127 bits, a seemingly arbitrary number, yet it appeared again and again, like a digital watermark. When this sequence was mapped visually, using techniques that translate binary data into spatial coordinates, it formed intricate geometric patterns. These weren't simple shapes. They were complex, multi-layered structures that scientists agreed couldn't possibly occur naturally through random processes or known physical phenomena in interstellar plasma. The moment they saw this undeniable structure emerge from the chaos, everything changed. The creeping suspicion hardened into a startling hypothesis. This wasn't just a glitch. It wasn't just noise. It looked for all the world like a message. The question then became, who sent it and what does it say? The contents of this potential message, as deciphered by the ongoing quantum analysis, are even more mind-blowing than its discovery. It's not a simple hello. The 127-bit sequence and the data surrounding it contains embedded mathematical constants, numbers like pi, or the golden ratio, phi. But crucially, constants that were not part of Voyager 1's original programming or expected telemetry data. These constants are arranged in highly specific ways that strongly suggest deliberate encoding, like finding a perfect equation written on a beach. It's information, not accident. Renowned physicist Brian Cox had previously theorized, almost prophetically, that quantum computing might be the key to unlocking hidden patterns in vast astronomical datasets, patterns too subtle or complex for conventional analysis to ever pick up. He imagined finding faint signatures of unknown physics, or perhaps even alien technosignatures buried in the cosmic background radiation or the light from distant stars. But nobody, likely not even Cox himself, expected it would be used to potentially uncover an intelligent signal embedded in the transmissions of our own spacecraft. While the full decoding is a painstaking process still underway, the early results point towards something that fundamentally defies conventional explanation. The decoded sections contain extraordinary information, a precise mathematical sequence unlike anything NASA programmed into Voyager. At its heart lies a series of prime numbers 2, 3, 5, 7, 11, and so on, the fundamental building blocks of mathematics, often considered a universal language. Following these primes, the message transitions into what appears to be a set of coordinates, expressed not in simple terms, but through sophisticated mathematical ratios, perhaps pointing to a location or a set of physical parameters. Most striking, however, is the presence of what seems to be geometric instructions. When these instructions are rendered visually using computer modeling, they create a complex, three-dimensional spiral structure. And embedded within this spiral are recurring symbols. These symbols don't match any known human language or code, but they follow a coherent, internal logic and pattern, suggesting a form of language or mathematical notation far more advanced than our current understanding. It's like finding hieroglyphs, but in 3 dimensions and expressed through pure mathematics. Are these instructions to build something, a map, a representation of a physical law or structure? But the quantum analysis revealed something potentially even more shocking, something that touches the very fabric of reality. Embedded within the message are representations of fundamental physical constants, numbers like the fine structure constant, which governs the strength of electromagnetic interaction, and Planck's constant central to quantum mechanics. These are numbers we believe are universal and unchanging throughout the cosmos. However, the values embedded in the Voyager message show slight but consistent variations from our currently measured values here on Earth. And crucially, these variations aren't random errors. They form their own distinct pattern, potentially conveying an additional layer of information, or perhaps suggesting that these constants aren't quite as constant as we believe, or that the sender exists in a region of space or a state of existence where these values are subtly different. What could that mean? Let's address the skepticism head-on, because extraordinary claims require extraordinary evidence. Why can't this just be a very complex equipment failure? Several factors argue strongly against it. First, the signal contains highly specific mathematical sequences of prime numbers, sophisticated ratios, representations of physical constants that simply weren't programmed into Voyager. The spacecraft's 1970s-era computers, while robust, lack the computational capacity to spontaneously generate these incredibly complex, information-rich patterns. This isn't like a random bit flip. It's like a typewriter randomly typing out Shakespeare. Second, the message includes mathematical relationships and structures that scream intentional encoding. The way the primes lead into ratios, the geometric instructions, the pattern variations in physical constants, these require foresight and design. Third, noise and interference, whether from failing hardware or interstellar plasma, follow predictable statistical patterns of randomness. Noise degrades information. It doesn't typically create new, highly ordered information structures. This signal fundamentally defies those statistical patterns. In fact, statistical analysis performed by the quantum computing team places the probability of this specific, structured 127-bit sequence and its surrounding patterns occurring naturally, through any known random process, at less than 1 in 10 to the power of 87. That's a 1 followed by 87 zeros. To put that in perspective, the number of atoms in the observable universe is estimated to be around 10 to the power of 80. Statistically speaking, it's virtually impossible for this to be a random fluke. Furthermore, the quantum pattern recognition methods used to identify this signal weren't pulled out of thin air. They were developed building upon the groundbreaking research of theoretical physicist Michio Kaku. Kaku has long explored how we might detect signs of advanced intelligence, not necessarily through radio shouts, but through subtle artifacts or patterns embedded in natural phenomena, like the cosmic background radiation left over from the Big Bang. His algorithms are specifically designed to differentiate between patterns generated by known natural physical processes, like plasma fluctuations, gravitational lensing, etc., and potentially engineered signals, by identifying mathematical structures and complexities that nature, as we understand it, doesn't produce. The Voyager signal tripped these specific algorithmic flags, indicating a high likelihood of artificial origin based on Kaku's criteria. Perhaps the most compelling piece of evidence pointing towards an external intelligence is this. The message appears to contain a direct response to information encoded on Voyager's golden record. Both Voyager 1 and 2 carry these gold-plated copper discs, time capsules containing sounds and images selected to portray the diversity of life and culture on Earth. They include greetings in 55 languages, music, natural sounds, and significantly, mathematical and scientific information, diagrams of our solar system, basic units of measurement, depictions of fundamental physics concepts. The decoded message fragments seem to specifically reference some of this mathematical and scientific information, almost as if the sender studied our message in a bottle and is now replying in a similar mathematical language. This suggests not just intelligence, but an intelligence that has encountered Voyager, understood its purpose, and is attempting a dialogue based on the content we provided. This leads us to the trillion-dollar question. If this message is real and artificial, where is it coming from? The signal's strength and characteristics don't quite align with what we'd expect if Voyager 1 itself were simply malfunctioning in a complex way, or even if it were the sole originator of this new, complex signal. The energy requirements to generate such a dense, structured signal seem beyond its aging power source, even with its better-than-expected performance. This has led scientists to a startling hypothesis. Something, or someone, appears to be using Voyager 1 as a communication relay, like hijacking a postal service truck to deliver its own mail. The question then becomes infinitely more complex. Who or what is on the other end of the line? Scientists are now grappling with 3 major theories, each with profound implications. Theory 1: external interception and modification. This theory suggests that an unknown external intelligence, somewhere between Voyager 1 and Earth, is intercepting Voyager's standard telemetry signals, modifying them to embed their own message, and then retransmitting them towards Earth. What supports this? The signal strength hasn't significantly dropped, despite the massive increase in information complexity. The transmission characteristics, frequency, modulation, still largely match Voyager's hardware capabilities, suggesting something is cleverly piggybacking on the existing communication channel without overwhelming it. The challenges. This would require incredibly advanced technology. Imagine trying to catch a faint whisper directed specifically at Earth from 14.5 billion miles away, decode it, encode your own complex message within it, and beam it back precisely along the same path, all without disrupting the original signal's basic carrier wave detectably. It's a feat far beyond our current capabilities. And why choose Voyager 1 specifically? There are other probes, though none as distant in interstellar space. Is its location significant? Or was it simply the first one they encountered? Theory 2, a dormant program. This theory posits that these complex patterns weren't introduced externally, but were actually encoded into Voyager's systems from the very beginning. A kind of hidden, dormant program designed to activate only after the spacecraft reached true interstellar space. The timing is intriguing. Voyager 1 crossed the heliopause, the boundary where the sun's influence gives way to the interstellar medium, several years ago, and these signals began relatively recently, perhaps triggered by long-term exposure to the interstellar environment or reaching a specific distance marker. Some elements within the decoded mathematical sequences bear a faint resemblance to structures used in early NASA programming languages, lending a sliver of credence to this idea. However, this theory struggles to explain the sheer sophistication and information content of the message, which seems far beyond anything achievable with 1970s computing technology and programming foresight. Furthermore, former NASA engineers who worked on the original Voyager mission have emphatically denied that any such hidden, complex message-bearing programs were installed. They were focused on the primary mission objectives. Was there a secret, unacknowledged project? Or is this explanation simply inadequate? Theory 3, an encounter. This is the most direct and perhaps most controversial theory. It suggests that Voyager 1 has actually encountered something tangible in interstellar space, perhaps an advanced alien probe, a piece of derelict or active technology, or even a presence representing an advanced civilization itself. The gradual increase in the message's complexity over the months could indicate an intelligence that is actively learning how to interface with and communicate through our technology, perhaps starting simple and becoming more sophisticated as it analyzes Voyager's systems and our previous attempts to fix the garbled data. The message's apparent reference to information on Voyager's golden record strongly supports this theory. It implies direct interaction with the spacecraft and its contents. The main counterargument is that Voyager's onboard sensors haven't detected any physical objects nearby. However, critics quickly note that Voyager's instruments were designed primarily to measure particles, fields, and plasma in the heliosphere and immediate interstellar space. They weren't designed as alien detectors and might easily miss objects that are stealthy, non-reflective, or exist in forms of matter or energy we don't currently understand or anticipate. Adding another layer of profound mystery is the timing of all this. These bizarre, structured signals began appearing precisely around the time Voyager 1 experienced its most recent, significant communication issues back in February and March. The spacecraft suddenly started sending garbled telemetry, which NASA initially diagnosed as a problem with a specific memory chip within the Flight Data System, FDS. JPL engineers cleverly devised and uploaded a software patch, relocating the affected code to a different part of the FDS memory. And just as they confirmed the fix was working and expected normal telemetry to resume, these new, complex, structured patterns emerged from the noise. This coincidence is too significant to ignore. Did the initial glitch wasn't a glitch at all, but perhaps the first attempt by an external entity to interface with Voyager, causing the system to malfunction in ways we misinterpreted? Did NASA's fix inadvertently stabilize this connection or create a vulnerability, effectively opening a communication channel that something else could then utilize more effectively? Or if Theory 2 holds, did the software reshuffle accidentally trigger the dormant program? The confluence of the malfunction, the fix, and the message's appearance is a critical puzzle piece that doesn't neatly fit any single explanation yet. So what does NASA, the agency responsible for Voyager, officially say about this potentially world-altering discovery? Their public response has been, perhaps understandably, cautious and guarded. There's a palpable tension between the raw data and the immense implications. NASA's official statements acknowledge the detection of unusual and complex data patterns, in Voyager 1's transmissions following the recent FDS fix. They confirm these patterns are undergoing rigorous analysis. However, they carefully stop short of confirming any non-human origin or even using the word message. Their press releases describe it as a complex signal requiring further analysis, while simultaneously emphasizing that, post-fix, Voyager's core engineering systems appear to be functioning within expected parameters, a subtly confusing message in itself. Behind this veil of cautious public relations, however, internal dynamics paint a more dramatic picture. Reports, allegedly based on leaked internal documents and anonymous sources within the agency, suggest heated debates are occurring. The quantum computing team, armed with their pattern analysis and statistical data, are reportedly pushing for a more open acknowledgement of the signal's artificial nature. On the other side, senior administration officials and perhaps more conservative elements within the scientific leadership are urging extreme caution, emphasizing the need to exhaust every conceivable natural or technical explanation before even hinting at extraterrestrial intelligence. There are disagreements about data interpretation, the reliability of the quantum methods, and crucially, how and when to communicate this to the public. Interestingly, other major space agencies seem less hesitant. The European Space Agency, ESA, perhaps feeling less direct pressure, has reportedly taken a bolder stance. Their director of science purportedly announced an emergency allocation of resources, telescope time, computational power, expert analysis, to study the signal independently, aiming to verify or refute NASA's findings. China's National Space Administration, CNSA, has allegedly redirected elements of its powerful deep space listening arrays, including the FAST telescope, to specifically monitor Voyager 1 and attempt their own detection and decoding. Russia's Roscosmos has reportedly called for immediate international cooperation, urging the formation of a united scientific front to tackle this potential discovery collectively, emphasizing transparency. Within the broader scientific community, the discovery has ignited unprecedented debate and division. The International Astronomical Union, IAU, the governing body for astronomical nomenclature and standards, reportedly convened an emergency virtual session last week. Accounts suggest it was a fiery meeting, pitting quantum physicists and information theorists, excited by the novel patterns revealed by the Majorana chip, against veteran SETI researchers, who preach caution and adherence to established protocols built over decades of searching for more conventional radio signals. The quantum team presented their compelling mathematical evidence, the low probability of randomness, the complex structures. The SETI veterans argued, rightly, for exhausting all mundane explanations first: complex interactions with the interstellar medium, unforeseen consequences of the FDS fix, even subtle forms of terrestrial interference that might have contaminated the signal before quantum processing. Skeptics raise several legitimate concerns that must be addressed. First, the quantum interpretation methods themselves are incredibly new. The Majorana 1 chip and the specific algorithms like QPA-7 are cutting edge. They don't yet have the decades of cross-validation and established verification protocols that traditional signal analysis methods do. Could the quantum system itself be creating patterns from noise due to its unique architecture or subtle biases in its algorithms? It's a phenomenon known as apophenia, seeing patterns where none exist, potentially amplified by the quantum realm's complexities. Second, related to this, could the specific architecture of the Majorana 1 chip, perhaps its topological qubits or error correction codes, be interacting with the specific type of noise from Voyager in an unexpected way, generating artifacts that look like patterns but aren't truly encoded information? Third, despite NASA's best efforts, could there be an unknown source of terrestrial interference? Perhaps a novel form of electronic noise or even a deliberate spoofing attempt, subtly affecting the faint Voyager signal before it even reaches the quantum computer, creating the illusion of a structured message. To rigorously address these crucial concerns, an unprecedented international verification effort is now underway, operating with remarkable speed and collaboration. 3 independent quantum computing teams, using different quantum hardware architectures and algorithms, are analyzing the raw, unprocessed data from Voyager 1 separately. NASA has activated backup communication antennas and protocols to interact with Voyager 1, testing if the anomalous signal persists across different transmission pathways, which could help rule out issues specific to the primary communication link. Most significantly, the Deep Space Network, DSN, the network of giant radio antennas worldwide that communicate with interplanetary spacecraft, has implemented a new, stringent signal isolation protocol. This involves advanced filtering, signal triangulation using multiple DSN stations simultaneously, and cross-correlation techniques designed to eliminate any possibility of terrestrial signal contamination, mimicking a deep space origin. Crucially, the verification teams are interdisciplinary, including specialists from both the cutting-edge quantum computing field and the established disciplines of deep space communication, engineering, and traditional radio astronomy. They are working in parallel but constantly cross-checking each other's findings, ensuring that any confirmation is robust and withstands scrutiny from all angles. The initial timeline for this verification is remarkably compressed. Preliminary results are expected within weeks, not months. The scientific world is holding its breath. So, while we await that verification, what could this message mean? If it is indeed confirmed as an authentic, intelligent signal from a non-human source, this discovery fundamentally transforms the entire landscape of the search for extraterrestrial intelligence. For decades, SETI has largely focused on passively listening for deliberate, powerful radio or optical broadcasts aimed at Earth from distant star systems, assuming another civilization would try to contact us directly. The Voyager signal suggests something far more subtle, perhaps far more common, and profoundly different. Intelligent entities that might not be shouting into the cosmos, but are capable of detecting our technological presence, intercepting our transmissions, decoding them, and then responding using our own technology as a medium. This shifts the SETI paradigm dramatically. Instead of just passively listening to the stars, we may need to start actively analyzing our own deep space assets and their communication streams for signs of external interaction or embedded responses. It suggests a more complex, interactive cosmic ecosystem than previously imagined. This potential breakthrough has already triggered an immediate overhaul of how deep space communications are processed. NASA has reportedly begun implementing quantum analysis protocols, similar to those used on the Voyager signal, for data coming back from the New Horizons mission, currently exploring the Kuiper belt beyond Pluto, and the still operational Voyager 2 spacecraft, also in interstellar space, but in a different direction. The vast archives of data from the James Webb Space Telescope are also being slated for re-examination using similar quantum algorithms, searching for subtle patterns or correlations in light signatures that might hint at artificial structures or phenomena invisible to conventional computing. Perhaps most excitingly, the quantum detection method is being retroactively applied to decades of archived data from previous deep space missions. Scientists are reprocessing transmissions from the Pioneer 10 and 11 probes, also heading out of the solar system, the Galileo mission to Jupiter, and the Cassini mission to Saturn. Could similar patterns have been present in their data streams, dismissed as noise or unexplained anomalies at the time because we lacked the tools to see them? It opens up the tantalizing possibility that hints of contact might have been sitting in our data archives for years, waiting for the right key, a quantum key, to unlock them. The philosophical implications, if this is verified, are almost too profound to fully grasp immediately. This would represent the first confirmed contact with non-human intelligence, but crucially, it wouldn't be them arriving on the White House lawn or sending an obvious, "take me to your leader" radio blast. It would be contact initiated through interaction with our most distant technological ambassador, a silent, almost covert acknowledgement. It suggests an intelligence that recognizes and perhaps respects, or is merely curious about, human technology, choosing to respond via that channel rather than initiating contact on its own overt terms. It forces us to reconsider our place in the universe, not necessarily as the sole occupants, but perhaps as newcomers whose first tentative steps into the cosmos have finally been noticed. Beyond astrobiology, the scientific implications could be revolutionary. As mentioned, the message's apparent mathematical content, particularly the slight variations in fundamental physical constants, could offer unprecedented insights into fundamental physics. Do physical laws vary subtly across vast cosmic distances? Is there a deeper layer to reality that these constants hint at? Could this be a clue to unifying quantum mechanics and general relativity, the holy grail of modern physics? The quantum detection method itself represents a major breakthrough in signal processing and pattern recognition, with potential applications far beyond astronomy, in fields like medicine, materials science, and artificial intelligence. The timeline for answers is accelerating. Within the next 60 days, the International Verification Consortium aims to complete its analysis of the signal's authenticity. Is it definitively artificial and extraterrestrial, or can it be explained by some complex natural or technical phenomenon? Within 90 days, if authenticity is confirmed, experts hope to have a more complete mathematical interpretation of the message content. What are the coordinates pointing to? What do the geometric instructions represent? What is the significance of the varied constants? And perhaps the most ambitious goal, if the signal continues and its nature is confirmed, scientists hope to devise and potentially attempt to establish a rudimentary two-way communication protocol within 120 days. Could we actually ask questions and receive answers? What scientists hope to learn extends far beyond simply confirming the message's origin. The primary questions revolve around the nature of the intelligence behind it. Is it biological like us? Purely technological, perhaps artificial intelligence far beyond our own? Or something entirely different, operating on principles we can't even conceive of? Does it originate from within our Milky Way galaxy, or is it potentially intergalactic? And the most pressing question, why now? Why choose Voyager 1, and why reveal themselves or itself in this specific, subtle manner after decades of silence? As the esteemed astrophysicist Neil deGrasse Tyson has put it, this potential discovery stands as possibly the most significant moment in human scientific history. While rightly cautioning against jumping to conclusions before the rigorous verification process is complete, he emphasizes that quantum computing represents a fundamentally new lens through which to view reality. It's a tool that might allow us to perceive patterns and structures that were simply invisible to previous generations of scientists, locked away within the complexity of data. If this signal is authenticated, Tyson noted recently, it doesn't just change astronomy, it transforms our fundamental understanding of our place in the cosmos. It rewrites the human story. To appreciate the context fully, let's briefly touch upon some of the remarkable engineering behind Voyager 1 that even makes this scenario plausible. While its general history is well known, few realize the intricacies enabling its operation so far from home. Its power source, the radioisotope thermoelectric generators, RTGs, use the heat from decaying plutonium-238. Due to a quirk in the specific plutonium, isotope's decay profile and better than expected thermal efficiency, The RTGs are actually producing about 15% more power at this stage than engineers originally calculated back in the 70s. This unexpected power bonus helps explain how Voyager can still maintain signal integrity and operate key systems despite stringent power conservation measures. Furthermore, Voyager's communication system uses a sophisticated error correction scheme called Reed-Solomon coding, combined with an unusual implementation of convolutional coding. This complex layering, designed to protect the data from errors caused by solar radiation and detector noise near Earth, inadvertently created a signal with a high degree of inherent mathematical structure and redundancy. When subjected to the subtle filtering and scattering effects of the interstellar medium, the thin gas and dust between stars, this already complex signal might have developed nuances that conventional analysis, expecting simpler noise patterns, couldn't parse, but which a quantum computer looking for deep correlations could interpret as layered information. On the receiving end, the Deep Space Network, DSN, has undergone significant upgrades recently. Its signal processing matrix now uses an advanced combining algorithm that precisely synchronizes the phase of signals received at multiple giant antenna stations simultaneously, e.g., in California, Spain, and Australia. This technique achieved a crucial 7.2 decibel gain improvement, essentially making the DSN's ears significantly more sensitive, allowing it to pick up fainter signals and, potentially, the subtle, embedded quantum patterns within Voyager's carrier wave that were previously lost in the noise floor. And the Majorana 1 chip itself is a marvel. It utilizes topologically protected qubits, which are inherently more resistant to environmental noise and maintain their quantum state, coherence, about 1,000 times longer than previous generations of quantum bits. Its advanced 3D error correction code allows it to scale up the number of qubits without suffering the crippling decoherence issues that plagued earlier planar designs. It can operate at relatively warmer temperatures, 0.4 Kelvin, still incredibly cold, but easier to achieve than millikelvin environments, making it more practical. This extended coherence time, over 900 microseconds, is critical. It enables the chip to perform complex calculations like quantum Fourier transforms, essential for signal analysis, with very high fidelity across many qubits simultaneously, which is precisely what's needed to detect faint, complex patterns buried in noise. The specific quantum pattern recognition algorithm used, designated QPA-7, employs an entanglement-based search methodology. Instead of just analyzing the signal's properties directly, it cleverly looks at the quantum interference effects between multiple potential interpretations of the signal, essentially using quantum weirdness to highlight non-random structures by seeing how different possible patterns constructively or destructively interfere with each other. It's a radically different way of finding needles in haystacks. Finally, the verification protocol is incredibly thorough. It includes creating a highly detailed digital twin of Voyager 1's entire communication system and the interstellar medium it's traveling through. By running quantum simulations on this digital twin, scientists can meticulously test whether any known spacecraft subsystem failure, software glitch, or interaction with the known interstellar environment could possibly replicate the specific complex patterns observed. If the simulations show that none of these known effects can produce the signal, it dramatically strengthens the case for an unknown, external, and potentially intelligent origin. This quantum decoding of Voyager 1's mysterious signal represents an extraordinary convergence, humanity's age-old quest to know if we are alone, meeting our newest and most powerful computational technology. As we stand on the cusp of potential verification, the implications ripple outwards, touching not just astronomy and physics, but philosophy, theology, and our very definition of life and intelligence. Whether this signal originates from an advanced intelligence subtly hijacking our probe, an unknown natural phenomenon lurking at the boundary of interstellar space that mimics intelligence in ways we don't understand, or something even more exotic and unexpected, one thing feels certain. Our perception of the vast, dark void between the stars has been irrevocably altered. We thought we were just listening. We may have been heard, and now, something might be whispering back through our own messenger. The international teams continue their analysis around the clock. Major announcements are expected within weeks. If communication can be established, humanity may soon take its first tentative steps into a larger cosmic conversation. This entire, unfolding saga, regardless of the final outcome, offers a powerful lesson. It reminds us that sometimes, the most profound discoveries aren't waiting for us out in the farthest reaches of the universe, but might be hidden within the familiar, concealed within the noise we've learned to ignore. It underscores the critical importance of developing new tools and new perspectives, like quantum computing, because our existing methods might simply be blind to certain aspects of reality. Just like in our own lives, we often get stuck in patterns, filtering out information that doesn't fit our expectations. This story urges us to embrace anomalies, to question assumptions, and to cultivate a relentless curiosity. Breakthroughs often happen when we dare to look at the static and ask, what if it's not noise at all? Perhaps the biggest discoveries in science and in life require us to simply change the way we listen. This is a story that invites speculation and wonder. What do you think is the most likely explanation for Voyager 1's strange signal? If it is an alien message, why communicate in such a subtle, almost hidden way? And what question would you want to ask first if we could establish a dialogue? Share your theories and thoughts in the comments below. I'm genuinely curious to hear your perspectives. Thank you for joining me on this exploration into a potentially history-making mystery. I hope this deep dive has been thought-provoking and perhaps even inspiring. Wishing you good health, clear skies, and an ever-curious mind. Don't forget to subscribe. We'll be tracking this story closely and bringing you updates as soon as they break. You won't want to miss what happens next.